start our session. Let me share my screen. All right, so session. All right. So I hope my screen is visible to all. Please confirm it is visible to all.
Yes, sir.
All right. Okay, so I hope today was a good session for all, and you guys understand the good policy, and especially we discuss about that centralized policy for the different use cases. And let me log in my vManage as well. I will go and I will log in my vManage. But before I will just check what is my IP address. IP config. This is going to be okay. Why the second NAC is not available? I believe I disabled the NIC. Okay, let me check it. But I've disabled the NIC, then how I was able to log in? Okay, I got it. So this is required from the vManage, not from this one. So let me go here and admin. I'll put the password. So interface tab. So my IP is 121. So I will log in this. This is going to my cardless SD-WAN. This is going to my this cardless SD-WAN. Click OK. I will go. Let me just refresh it. Okay. Now I will just log in my controller as well. So controller is going to be this one. Admin. Log in this one. After that, this is not needed. I will need the switches for the testing point of view. So I will log in this switch. And I will log in this switch as well. Okay, what else? I will log in this hub switch as well. Okay, and now I'll go in this particular root CA. And this root CA, I will simply log in this MOVA Extreme. And I will get the CLI access of my all CH routers. So already we added this in our okay, it's not responding. Let me check, guys. 192.1.2.2. Oh, we don't have the reachability for some reason. Let me ping 123.1.1.1. It's reachable. 10 reachable. 11 reachable. Okay, so let me go here and check my first. I'm going to check my BGP session. Show IP BGP summary. Yeah, so at least we have one transport up and working. Now let me check this internet router. Will they have reachability or not? So I will check from here and I will try to verify the point-to-point circuits. Might be this router having some issue. So I will check that 1.100. It is not pinging. Okay. So it looks the issue with my internet router. I need to reboot this. So let me just verify one more circuit. 1.2.2. It's pinging. 3.3. It's also pinging. Okay. 4.5. It's pinging. 5.5. It's pinging. But this is not pinging. Let me retry it. So I will go here. I will check it from here. Show IP interface brief. We have the 100 IP address. This link having some issue. That's why the internet is not able to ping. So let me try one more time. Okay, so what I'll do, I'll just reboot this router first, and then we'll see that. So we lose the connectivity because we make the internet-based connectivity to the my SSH terminal. So let's wait for a while, and then we'll wait for a while, guys. Let's wait for a while. We'll fix this, and then we'll continue our policies. So already we did a lot of policy discussion, guys. We completed the application of a routing policy. We completed the route linking policy. We completed the VPN membership policy. So we'll continue after that. So my training and the topic. So we'll try to configure today. QS policy I'm going to explain. We'll see how QS policy is going to be applied. So first I'll explain and then we'll go and see that step by step how it is going to be applied.
Sir, I have a question.
Mm-hmm.
Actually, yesterday I was not available, so I saw one of the video is uploaded. That is for the route-based policy, and where we rejected, right? That was for rejected one, right?
Mm-hmm.
And earlier we also configure one route-based policy that was allowed, right? Accepted one.
That was TLOC based policy. That was TLOC based. TLOC we rejected, route was allowed.
Route was allowed, right?
Yeah, TLOC was rejected in that
Yeah.
policy. Only. So we did 3 policy discussions, Akhtar. Okay,
Mhm.
let me give the clarification. The very first one was default, right? We make
Mhm.
it default hub and spoke. You understand that one?
Yeah.
Where we added the default route.
Hmm.
Second, I discuss again TLOC means I allowed a DC TLOC. And when I allow
Correct.
DC TLOC, default route not needed.
Yes. Correct.
Clear? So
Hmm.
this was TLOC based hub and spoke.
Mhm.
Third, I discuss about the route base. Means route base means I reject the route for the branch. Means the spoke route need to be rejected. But once we reject, we lose the all connectivity. So we again inject the default route from DC. So that is a third discuss scenario.
So what was this first and last one difference?
Same,
It's same only, right? Default hub spoke and route based.
same, but default you don't have to use any brain, but here use your brain. Same policy both. Default is just based on a template.
Okay.
You
So
put the
back,
value and policy created, but here you created the manually. That is the difference.
now,
Now clear?
yeah, somewhat, I think. Yeah.
Yeah, you just go and learn. You're going to be clear.
Sure,
It's
sure.
very
I will.
easy. It's not very big deal. So let me try to ping again. Yeah, now it's pinging. So 2.1 is also pinging. So you have some issues, so you can just do the troubleshooting like this. Okay, so now if I go and root CA, okay. So we have this all access to the router. Now, guys, we have to discuss one more policy. We discuss about the application routing policy. We discuss about the external policy. We discuss about the hub and spoke three type of policy. We discuss about that application routing policy. We discuss about the route leaking policy, and we discuss about the that external routing policy, VPN membership policy as well. Now we have to understand about the QoS policy. What is a QoS? I will explain what is a QoS and how QoS is going to be configured and how it is going to be used in our policy framework. But before I can explain the QoS, we have to understand the QoS concept in the SD-WAN, how QoS is going to work and how basically the QoS is going to be applied in the SD-WAN. So this is the PPT I'm going to refer, and you can see the QoS overview. So basically this QoS is classified as per the VH, but the concept is going to be same for the CH as well. So don't be confused. Whatever the policy you are going to create, that is going to be applied for the VH and CH. So you can see here when the QoS is going to be designed, you have some ingress interfaces, right? Where the traffic is going to come. Means any QoS you are going to design. So this is your router, not only the SD-WAN, normal router. So your LAN are going to get very large speed of traffic. Means they are going to be 10 Gbps traffic. They are going to be get 1 Gbps traffic, and your WAN is going to be your low speed traffic. Means this ISP is going to be there, and this is going to be might be 100 Mbps traffic. You might be have the 500 Mbps traffic. So if you're sending very high speed traffic, you can understand in this way. Let's suppose this is a big pipe sending a lot of water, and below side we have the very small pipe. So what is going to be happen? If you're sending a lot of water, lot of traffic, it is going to be overflow. So if overflow is going to happen, your traffic might be going to be drop. So same thing happen. LAN side always going to be send very high speed traffic. Very high speed traffic means whenever going to be do the any LAN configuration, they are going to be get very high speed traffic. And if you go in the WAN and those LANs traffic are going to be as it is going to be sent, then your WAN is going to be choked and your traffic is going to be congested. Somebody is trying to go on the internet, might be he is not able to access the internet. Somebody is going on the cloud, they might be not able to go on the cloud. So this kind of things is going to be happen. So to manage these situations, when we design the any WAN infrastructure, so we design very carefully how much actually bandwidth we need to cater our business traffic. That is our goal. Means if I'm going on the internet or the any MPLS circuit, so how much bandwidth is going to require? It's going to be 100 Mbps, 200 Mbps, depend your business needed. And in LAN side, we have the multiple users. So multiple user definitely going to be do the lot of communication in the LAN. So LAN always going to have the very high traffic, but are the all traffic need to be processed by the your WAN? It's not really needed. What really needed? Let's suppose you are the network security architect and you have to design this QoS. So you have to understand how much voice traffic I have, how much bandwidth my voice traffic is going to. Let's suppose you're making that any kind of a telecalling services like IP phone and all. How many video traffic you have means how much bandwidth video traffic is going to take. how much traffic going to take by the Citrix, how much traffic going to be taken by your file servers, how many traffic going to taken by the cloud apps, and how many traffic you want to allocate for the general internet connectivity. And based on that analysis, means how it is going to be calculated. Your network architect, or you are the network architect, you're going to calculate how many users sitting in, and one user how much bandwidth they're going to consume, and based on that they're going to calculate these values. So you come to know I need only 200 Mbps. Let's take an example. You need only 200 Mbps. So you decided 200 Mbps. So behind the scene, means behind the LAN, we have the multiple users. Now you allocated 200 Mbps traffic, and you say like voice traffic need to be passed, video need to be passed, and you allocated the 200 bandwidth for the WAN circuit as well. But suddenly what happened in the daytime or nighttime, somebody start downloading the video from the internet, and he is using the complete 200 Mbps of the traffic. What is going to happen? The person who's trying to do any calling or video conferencing, they start getting the call drops or video freeze issues. The person who trying to upload the files for your database servers, or might be they want to connect with the cloud, they are unable to do that. That is something not good. One person is going to be consumed your entire bandwidth. And this is where the priority come and QS come in a picture. QS is a quality for the quality of service. Quality of service is basically it's giving the priority of the traffic. Means which traffic need to be processed and how much bandwidth we need to allocate. Which traffic we need to process and how much bandwidth we need to allocate. That is the key goal of our QS. So let's suppose if I have the different kind of the traffic, so I will allocate the bandwidth for a different traffic. Means if my voice traffic is going to come, so dedicated 40 Mbps traffic is going to be allocated for this one. If my video traffic is going to be come, then dedicated my 20 Mbps bandwidth is going to be there. If my Citrix traffic is going to come, dedicated my 50 Mbps bandwidth is going to be there. Similarly, other file, it's going to be 20 Mbps. How much this is? It's going to be 80 plus 130 Mbps is there going to be utilized. Rest 70 Mbps I will go for the general internet. So anything is going to be normal general internet. They will only consume for the 70 Mbps. They will not get services from the 40 Mbps. If there is a traffic, then the 40 Mbps is reserved for you. Means you can just think about it this way. Like you're going on the road, right? This is going to be your toll, right? And you decided a toll. So you might be put this is the one lane. This is going to be one lane. This is going to be your second lane. This is going to be your third lane. This is going to be your fourth lane. This is going to be 5 lane. You can say this lane is going to be dedicated for the VVIP, super VVIP. Mean like anyone is coming, like Prime Minister, President, any Chief Minister, they will come and they'll just simply go and out. You configure another lane for the VIP. VIP is basically less superior than VVIP. So they are going to be like your any kind of the other minister, MLA, they are going to become, but they might be have the large number. So they might be sometime get some little bit delay. Some lane you allocated for your defense people, policeman, other administrative, means any government officer. So they are going to use this one. Now these 2 laner for the general public. So what is going to happen? Their number is quite very high. So they keep in toll and they have to wait for the longer period of time. Once the toll is going to free, then they are going to only process the traffic. If the toll is not free, then they are going to be basically have to wait. But these people are going to come and they're going to be pass the quick list. That is a priority. Similar way QS is going to do that. Means if the router, if there is a dedicated bandwidth to decide, based on that bandwidth, they are going to be allow the traffic for dedicated bandwidth. If your general internet bandwidth is 70 Mbps only, so all traffic in regard of how much he is accessing, only they are going to get maximum 70 and they will not disrupt to other pools. Clear? Now, keywords is going to use two terms if you're going to learn the keywords. One is going to be, one of the going to be term is going to be always the shaping. Another is going to be policing. What is shaping? What is the policing? So if you're going to apply the shaping is basically always going to apply on the customer router, C router. C router is basically known as a customer router. So they apply the shaping. Why shaping? I'm going to talk about that. And if I go for the P router, that is known as the provider router. They are going to apply the policing. So let's suppose you have a scenario. This is one of the C router, right? And this is one of the P router. And you connected the link like this one. All right. And I can just put it here. C. This is going to my P. Now you're saying that my link bandwidth is 100 Mbps. And you're also saying the 100 Mbps. Now think in the design point of view, what is happening here. So let's suppose your LAN traffic is coming from here. Take an example, your LAN traffic is coming from your backend. So might be this LAN traffic is going to be 150 Mbps. And you're sending all 50 Mbps on this particular link. So this will not going to immediately drop your 150 Mbps traffic. I'm just giving the example. If your 100 Mbps bandwidth is configured, you suddenly send the 120 Mbps traffic here. So it will not going to drop immediately your traffic. It will buffer your traffic. Okay, it is going to buffer your traffic. Where it is going to buffer, they are going to be, they are having the hardware queue and their software queue also. Means in the router, they use the hardware queue and software queue, just manage the traffic. Just think in this way. I can just put in this way. They have some queue here, right? And once exceed traffic is going to come, so they will store here. And also they will send 100 Mbps, but this also have the limit. It's not like you can store up to any extent. No, it's not like that. Let's suppose you have the 100 liter tank available here. So you can only store 100 liter. If more than 100 liter traffic is going to be there, so you definitely it is going to be overflow. But you cannot immediately like drop. You will wait for certain period. Let's suppose right now within 10 minutes, I'm sending the 120 Mbps traffic. Suddenly this tank is going to full. But after 10 minutes, I'm just sending the 80 Mbps traffic. So I have 20 Mbps free. So they will release gradually the traffic from here and tank is going to be free. Again, it's going to be spike, again going to be store. Again, it will release when I have the linear traffic. This is how shaping is going to work. So shaping is not going to be your brutal in nature. Is not going to drop your traffic. It will try to handle your traffic. But when you talk about the policing is basically going to apply on your provider as router. And each provider is not having the one customer. They have the multiple customers. And their hardware are limited to the, handle the traffic. So they are very strict. If you have the 100 Mbps, if you're going to send even 1 Mbps extra traffic, it will simply drop. They will not going to hold any traffic for any kind of the requirement. It makes sense, policing and shaping, guys. Any doubt? Okay, so moving further, how it is related with my keywords of the SD-WAN. So this is going to use the same concept. Your traffic is going to come from the different source. They use the centralized policy, localized policy to build this QS. But first understand the QS framework. So WAN is going to have this kind of the different traffic, voice, best effort, business traffic, IPsec tunnel is going to be egress interface. So all traffic is going to come and these traffic are going to be mapped in different queue. So the queue number is going to be lower. They are going to be treated as a high priority traffic. And generally we use for the voice. and the Q1 is going to be second high priority for the video. And then we can send other traffic like base effort, business traffic and all. And these queue are going to be classified. And each class we having the some traffic. So we have to do the classification for the queue, which queue belong to which class, and which class having the which type of traffic. And based on that, we apply some conditions and some kind of the policy enforcement. So you can see, based on the classification, we allocate the queue, and after allocating the queue, the third step, we are going to allocate the bandwidth. Means how much bandwidth we require per queue. Means if voice traffic is coming, then how much bandwidth I need to give. Same concept which I discussed earlier, but it is in the queue format. And total 8 queue is going to be there. 0 to 7 is a 8 queue. And also they are going to discuss about that Q2, Q3, Q4, Q5, how much bandwidth. And if congestion is going to happen, what is the congestion method they are going to use, right? And finally, once you configure these all things, we have to apply the QS on the your egress interface. That is my exit interface from where the traffic is going to be out. Clear? So this is the things we have to understand in the QS. And now we have to configure the same structure in our SD-WAN solutions. Okay, so let's start the configuration, guys. How to do a step-by-step configuration. So if you want to do the QS configuration, so very first thing, we have to understand, let me close these slides. You have to give the bandwidth of the any interface. Let's suppose I want to give the bandwidth of the any interface, and from there I want to pass the traffic. So what is the bandwidth is going to happen? So let's suppose I want to give the bandwidth of the interface, let's suppose 10 Mbps or 20 Mbps. So I need to configure, let's suppose for this site, let's suppose VS3 or VS2, I want to just do some QS testing and I want to apply the bandwidth for the MPLS link or by the internet link, any link I want to apply the bandwidth. So how I can apply that bandwidth? So bandwidth is going to apply the very first thing when you want to do that on the template basis. So let's suppose right now there is no bandwidth. So I will go in the template, and this is somebody asking something. My voice is coming low, guys. Is it for all?
That's good to me. Fine.
Yeah, it's slightly better than yesterday, sir.
Now tell me it's fine.
Yes, sir, it's fine.
Okay. Okay. It was low earlier.
You are not drinking, right? No.
Sorry?
You are not drinking? No.
Not?
No. Drinking.
I don't understand. Trunking?
Drinking beer, cognac, liquor? No.
No, nothing. No, actually, there was like audio settings, and it was the volume was little bit low, so I just increased that volume. Okay. So basically, what I have to do that I have to go here classic template, and after going classic template, I go in the template, and I need to set the bandwidth on the interface level. So I need to go in feature template. Let's suppose I want to set up for the MPLS interface gig 0 by 0, for example. So I will go here. And I will found MPLS, and I need the interface template for the MPLS for dual site only. So VPN 0, yeah, MPLS, this one, the my transport 0. So I will go here. Okay, here is a QS. Sorry, I was searching above. So we have to give the bandwidth here, the kbps. So you want to give the 100 Mbps. So you have to give 100 and 30. That is 100 Mbps. You want to give the 10 Mbps, 10 and 30. That is going to be 10 Mbps. So your shaping rate is going to apply is a 10 Mbps. So if you go here and check that, Let me check it here. So if you go here and check that show run interface right now, show run let me check first, show IP interface brief. And if I run show run interface, this is my interface. So I'll copy it. See, this is my normal configuration. And this, I have the bandwidth, which is right now is going to be your 1000 Mbps. It might be 1 GPS circuit, but I want to limit as a 10 Mbps for these two routers. Show interface, sorry, show interface gig 1. You can see it's a, so I'll configure the interface. So I'll go here, make it 10 Mbps. I'll update it. And you're going to find some configuration changes. Let's wait for a while. Config side by side and check. You're going to get a bandwidth allocation on the SAP average. It's BPS. We give that 10 Mbps, right? Okay. It should be. Let me check. Give me 1 second, guys.
It's taking in bit, I think. Bit, then kbit, and then MB.
Mbps is window bandwidth. This is something I'm saying very first time. Should be BPS, not kbps. Okay, so that's fine. It's calculating in the BPS, beat per second. So it's a 10 Mbps. That's correct. So we given the 10 Mbps calculating. So I just want to make sure, double sure you're doing right thing. So we configure it from here. Now I have done. So I just configure the interface. Now let me show you the configuration on interface from the CLI also. Post the template is going to push from here. It's done. Okay, done. So now let me check it here. First, I'll verify this. And default is still 10,000, but if you just check it, show run interface gig 1, this apply the service policy. Service policy, SAP, they have driven that. And show run service, sorry, so policy, there's a command. So service, what is the command? Show run policy. There is a one command, I can check that. Policy map. Okay, so you can see here, this is the policy map we configure as a SAP average, that is the BPS. So you just going to apply in the your interface. Now here also go and check that show run interface gig 1. If this come here and show run policy map, you will see this BPS. So this has been just save the interface as a 10 Mbps for just MPLS, right? Now we have to go and configure the first localized policy, guys. So now we are talking about the localized policy, and we create the localized policy. Does it going to travel to the vManage or not? Sorry, vSmart or not? Localized policy. If I'm going to,
it will not travel.
No.
right? So localized policy is going to state from the vManage to the VH router. So I'll go and configure one of the localized policy. We'll discuss more about that, how it is going to be done. But I will go here and create the localized policy, add policy. And I will create some class map, and this class map is going to be queue, okay? Because we have to do the queue mapping from here. So we'll see how the queue is going to map. So each class I'll give the some queue mapping. So I'll give here as a my class 1, and I'll just map as a Q0. So this class 1 is under the Q0. Now I'll add the class. Sai, any question? Okay.
No, sir. No, sir.
And class 2, I'll use the Q2. Okay, 3 classes I created. Okay, class 3, I need to put it here. We get a duplicate. So we have the class 0, class means Q1, Q0, Q1, Q2, and we have the respective classes. Or I can just make in better way. I can just put the 0. So we know which class is assigned for the which queue. It's up to us how you want to do that. And this is going to be my class 2. Okay, now I'll go here and create one more class. That is a class 3, going to be Q3. So 3 classes we created. Now I don't need the prefix list and all for time being, but now I'll go and click the next. And we have to map some bandwidth of each class. As you can see, we created the class, match the queue. Under the queue, you have to assign the bandwidth. That is our third steps. So we have to give the bandwidth. So just go here and add the QS, create new QS. And I will just put as the QS policy. I can give the name and see by default your all bandwidth is in the queue 0, 100%. But let's suppose I want to give some bandwidth for the class 1 to like that. So total 10 Mbps I have the bandwidth. So I want to allocate 2 Mbps for my 20 Mbps. So I'll put here 20 Mbps here. 20% is going to be 2 Mbps after 2. I'll give the buffer percentage anything, right? And this is that is going to see class 1 is by default taking. So class 1 is going to get your 2 Mbps traffic out of 10 Mbps. And if any congestion is going to happen, we'll use the tail drop. Tail drop is last traffic is going to drop. This is so you can see now 8 Mbps is here, 2 Mbps here. Now I'll add for the one more band queue, the Q2. See, it's taken by default class 2. I'll add one more 20 Mbps here and tail drop. So you can see the bandwidth is decreasing from the Q0. By default, everything is going to be in the Q0. But if you're mapping the bandwidth, this is decreasing from the Q0. So I'll go for the third queue. And this is going my Q3. And this is also going to be tail drop. Randomly you can put it. So now you can see 40% we have in the Q0, 20 we have the Q1, 20 we have the means 4 Mbps here, 2 Mbps here, total 10 Mbps. Now I'm good and I can go save the policy. So my local policy is created, guys. Now we can go next. We don't have to do any changes here. We can go next. We don't have to do any changes here as well. And we can go next. And I can give the policy name, QS policy. That's it. And you can see this is a policy I'm creating here. So you'll see I'm creating this policy. I'm saying that this is my different classes. They have the different bandwidth, buffer rate and everything. And this is the class map. Now I save this policy. This policy need to apply on the interface on the your CH router. Which interface? That is my MPLS interface. I need to apply. So if I want to apply in the MPLS interface, I simply go in the template. Listen carefully. I'm showing one of the problem. And I can go in the feature template. And I can go here. Let me show you today date. And this is my MPLS transport interface. I'll go here, edit template. Because this QS policy always apply on the interface level. So I need to apply under the interface which policy we created. So I'll go in the QS, and if you go in the interface, here's the QS map. You just give the name of the QS. What is the name of the QS? The name of the QS we configure that is the what was the name? Anyone able to recall? QS map. What was the name? QS map. I believe this was the name, right? Okay, let me open the
Policy map, you are telling?
no. I create the QS map. Now let me try to open the name in a different browser. Oh, 121. So I'll click it here. Skip for now. This one. And go for the configuration. Go for the policy. I want to check the name, which policy we created. So the name was this one, QS policy, sorry. So I need to copy this policy and I need to put in the here. But when I put it here, it will throw an error. Let me show you. If I update it, if I try to go next, check this. This validation itself should be failed. You can see server error. It's not doing the configuration. Why it's not doing the configuration? The problem is, guys, this trying to find this name in the running configuration. This name in running configuration. But we don't have this configuration available in my running configuration of the both router. If you run show run section QS, we are not going to find any configuration. So it is going to not apply on the interface. So we have to put this configuration on these routers. This local template which we created here, this need to push on the routers. So how we can push this configuration on the router? We don't have the option to activate this policy. You can see we don't have the option to activate this policy. So any policy I want to put on the router from the vManage, I need to go in the device template, and from there I have to attach it. Any localized policy, I need to send the any router. So we have to go in the device template, and from there we have to attach it. It makes sense. So I will go here configuration. It's a template. And this is my dual transport device template. I will go edit from here. Go down. And you are going to find the additional template here. In this, you have the policy, and here is your QS policy. So you have to add the localized policy from here. Now, once you update this localized policy, this policy is going to push to the routers. And then after you can verify applying this settings here. Means I was doing the under templates, I will do from here, second browser. So let me first show the configuration. It's going to be successfully pushed because we are going to add some new configuration side by side. So they are new configuration. We are pushing the router. So this name is pushing on the router. Which name? This policy map name is pushing in the router. No, this one not name. Sorry. This is the policy name. Why it's not showing the policy name? Match any group 3, match any Q0, policy rate, class, bandwidth Q0, random policy map. Hey, where is the name? There should be name also, no? Ah, here is class policy. What was the name? What do you configure the name? Wait 1 second. Let me go here in the my configuration policy. The name should be QoS policy, right? This we created somewhere. QoS policy. Class map, class map, class map. Should be there. QoS policy. Here is the name. Okay, I was just wondering why it's not there. So we have this name. Okay, so this name must be there, right? So if this name is not going to be available, it is not going to be applied on the interface. So we have this QoS policy name. So this is something we have to make sure it is. Now configure it. I'll configure the both devices. Okay, I will simply go here, add it. So both are successful. Now you check it here. If you run the show run section, QoS, say this is the QoS policy is there, right? And if you run the show run policy map, you're going to get this policy map is already there. And QoS is also, the QoS policy is there already. Now, once we have this QoS policy in place, I can apply this QoS policy on my interface level. So how can I apply it? I can just copy the same name and go in the my configuration, go in the template and go in the feature template, and I'll go in the my interface template. VPN 0, dual transport VPN 0, edit 0, and sorry, I need to go QoS, and this time you'll see it will not going to throw an error. Let's go apply global, and I will just put the name, same name. Make sure name is same. It should not change. Policy, and here is the policy. If it is going to be changed, it's not going to work because it's going to check the same reference value from your router. Next, now it should be validated. Earlier it was giving the error. Now it should not give the validation error. So till now we are in the localized policy only. We are not touching any centralized policy. You can see. So now if you go side by side, you are going to see somewhere in the below. This is the service policy QoS has been applied on the your interface level. So configuration this on the both devices. Now we have to put intelligence on this QoS. We have to put intelligence on this QoS so that can handle the traffic wisely. Means how we can put the traffic. Let's suppose my different traffic coming from the LAN side. I want to give that if my voice traffic is going to come, that is going to hit Q0, right? We created a Q now here. You can see if you create a Q0 and this we have the voice traffic we match here. Q1 we have the might be video traffic. Q2 I can give the Q2 not there. I miss some Q2. Okay, leave it. Q2 I miss. I believe somehow. Q2 I can put something else. So those things I need to put it here. Or let me try to see how I can miss this. Q2 should also there, right? QoS. Let me. Okay, I can only view from here. Q2 is there, right? Class 2 is there, so it's not showing here. Q0, Q1, Q3. Let me see that. It should be there. Oh, we have here is a queue. You can see class and queue is there. Might be some reason it's not showing in the syntax, but it's there, right? You can see in the queue here it's available. But something wrong in the policy map. It's not showing the Q2. Okay, we'll troubleshoot later. It's not very important for time being. We have to test. Now, how I can put the intelligence on this particular queue? Still, we have the QS, but still traffic is not going to be enter in the queue. We have to define the centralized policy, and I have to tell centralized policy has centralized policy. If certain traffic is going to come, we have to inject in the your queue. Which queue? Whatever the queue you want to do that. So for that, we have to go and create the centralized policy now. So I'll go here, configuration, and the policy. I need to add the policy from here again. And in this policy, we can define the group of interest if I want, right? Based on the prefix, based on something, but that is not needed as of now. We can simply click that next, and this is going to be your traffic data policy. Means any traffic data is going to come. So I am not going to touch anything from here. I will simply go here and touch the data policy. Means any data traffic is coming from my LAN. So I want to do some changes. So I will make the QS policy. And this QS policy, if I go here, copy and paste the name, I have the sequence where I can just define the custom QS policy, and based on that custom QS policy, I'm going to tell, see, here's the QS calculator, guys. Let me show you if you're not aware about the QS calculator. Calculator. And if you go in the image, there's a QS calculator. You have to mark the traffic based on the DSCP value. What is DSCP value? DSCP is the differentiated code point services. So differentiated service code point. And if you want to mark traffic for the any voice, you have to do with the 46 DSCP marking. If you want to do for the interactive video, you have to use either of the values, and videos normal, you can use this one, call string this one. So you can use this DSCP for the marking the traffic. So I'll use this DSCP value for mark my traffic and create my QS policy. So I'll go here and I will say, if my DSCP value is going to match 46, which is for the my voice traffic. Okay, if DSCP value is going to be 46, so what I want to do that for any prefix, I want to accept, and I want to give the forwarding class, and that is going to be my, what was the name? That is a class 0. That is the name I believe we given that. Let me verify. That's why I open the two things. So it is going to be there. It is going to be class 0. Yeah, class 0 is going to be your this one. Okay. So I will simply hit it, and also I'll put the counter as well. Counters I want to put the same. So any log is going to be there. So they are going to be just generate the logs counter in this particular things. Now I'll save this one. So I'm saying that any DSCP traffic coming, voice traffic is coming, you send the Q0. I'll duplicate this one. I will say if any video traffic is coming, that is my 34, 36, any value. Let me use the 36. So 36, I will need to put class 1 and counter is going to be class 1. Simple. Any traffic coming for mission critical, that is the 26. Mission critical is your organizational traffic. So I will give the 26 in the class 2, class 2. Now, the last entry I will say, any other traffic is going to come. Any other traffic, I'm saying that. Okay, anything is coming. I'm not going to match here any value. Any traffic is going to come means any other class. It's going to be class 3. So I'll match these sections. So you can see I'm saying that explicitly in my centralized policy. If any class traffic is coming for DSP 46, it is going to the class 0 and just going to use the counter as a Q0. 36, it's again counter in class 1. For 26, mission critical class 2. Any other traffic, it should go in the class 3. I will go default actions. I will keep the everything same. Now I'll save this policy. Clear? After saving this policy, I will go here next. And it will ask the name, the policy name. So I will give the keywords policy again here. Same name. Keywords policy. And I will go in traffic data and it will ask for which site and which VPN you want to apply. So I want to apply for the site that is my spoke site, that is site 2 and 3. And for VPN, I want to apply for VPN 10 only. This keywords. And from service, I want to apply. I will click add. And this is your final centralized policy. You can see it. In the centralized policy, you're saying that any traffic coming, any source, if they have the marking 46, you have to forward in this class. Any traffic coming from the marking DSP 36 for the video, this is class. Any traffic for DSP mission criticals, you have to give in this class. Any other traffic, any source without any marking coming, just send this one. For this site for this VPN, save policy. After saving policy, we are good. Now, if I activate this policy are going to be available in my end router or not? Any guess?
It's still not activated, no?
Yeah. If I activate, then it is going to be available on end router or not?
It
This is a
should
data,
not be.
this is a data policy. So we have already one activated policy, this one, application aware routing. So I mentioned only control policy is not going to be
Router.
available on your routers. Control and VPN membership policy. Data policy, any local policy, any application or routing policy is going to be available on the router. Okay. So now policy deactivated. If you check this command again, there is no policy. See, there is no policy. Now I activate this policy again, keywords policy. Why it's not going to be? So you see your policy has been activated and now you check it again, this command, you must see this policy available on the router. So already you apply your local policy on the interfaces. This policy is going to give the intelligence. Okay, what is intelligence? It will just help to take decisions. So SD-WAN policy from BSmart. Now, what I can do that, let me shut down this link for time being. Okay, so how can I do that? Okay, let me shut down. Okay, let me unlock this. You guys can shut down from router what we did yesterday. So I will simply shut down this link. I have just only one link from here, and also I will shut down from here. So only have the MPLS to MPLS communication. I haven't done any QoS configuration on this link, so that's why I want to test on the MPLS. So I will shut down this link also. Why it's not shutting it down? Come on. Okay. Suspended. Okay, now it's suspended. So if I check here, show. Oh, we lose the internet connections because we have taken the internet from there only. Oh my God. So let me resume this link. Let me resume this link. Okay, we'll test it indifferently. Don't worry. So we should have the access. Yeah, we have the access. Okay, we cut our legs. So that is the issue. Okay, this is again resumed. So what I can do that I will go and I want to test for this link only, not this. Okay, anyway, we'll check this. So we can just initiate some traffic, okay? So let me find the command first. I want to show you the command first. So let me go here and find the QS command. Where is the QS command? CH and VH routers. So for the QS testing, we have the command, say, this command we have to use for the your CH router. So I will just use a show SD-WAN policy data policy filter. So let me check show SD-WAN policy data policy filter. And you'll see there is no traffic in these queues. You can see these queues are completely free. We make the class 1, 2, 3, and there's a different queue. There is no traffic as of now in this queue. But I want to check, are they going to get any traffic? So if I want to send the voice traffic, that should be land in the this queue. If I want to send any kind of the what traffic, video traffic should be this link. Any kind of the other traffic should be like mission critical should be this link. So we'll send with a DSA marking. From where? We'll send with this router, this switch. Okay, so let me first check end-to-end testing is working or not. With source 10222. It's working. So right now I send the 5 packet, and this 5 packet should fall on which queue? It's correct or not, guys? I send normal ICMP packet and it's falling in the which queue? Q3. Is it aligned with our configuration or not? Everyone is
Yeah,
sleeping.
Q3 we did not configure this in
Q3 configured, na? Q3 we send, if a centralized policy, you will see that centralized policy, we configure the Q3.
Yeah, but we did not dedicate anything from voice video. We did not dedicate anything.
In Q3, we match any traffic, right?
Any traffic, yeah, any traffic.
Any traffic we matches in the Q3. How we can check that? Go in the policy. So ICMP is going to follow in the any traffic, right? Traffic policy, data policy, go here and check it here. Let me edit you. You see Q3, what we're saying, any traffic. So ICMP matching not any video, not voice, not your mission criticals. It's fall in the third conditions. That's why your traffic is hitting on the Q3. Make sense? Now what I can do that, I will go in the switch 2 and I will ping extended. I will ping extended ping, and then I will use the 10.333. Repeat count, let's suppose 10. Extended, yes, I want to use. And here I will set the source interface, this one. Now I will use the type of service. This time I will mark as a DSCP 46, EF 46. So I'll give that 46 value here. This is the voice traffic. So I'm doing the explicit marking here. No, 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 no. So which queue it should fall? Any guess?
One.
1 or 0?
Q1 voice.
We have the 0 class, 0 queue. So why is we match under the 0, na? It's not matching. Why? Strange. Let me try one more time. Should match 46 with it, no? Let me try one more time. I should 100% match 10, 3, 3, 3. Right, let me use the 20 this time. Extended years 10, 2, 2, 2. Let me use for this time is let me check it. Where is this one? So 26. Let me match for 26. Okay. 20 packet. This should be in the queue, right? Something weird. Interesting. No packet is landing. There could be region. You guys know what could be region? Anyone know why it's happening? There could be the flow-based communication. Our internet is still up and working. So this could be the only region. So I need to turn off the internet because we configure this QoS for the only MPLS. Might be that is the problem. But if I shut down the MPLS, it is not going to work. So okay, let me do in this way. I can shut down the here. I can shut down from here. Okay, I will go and I will take the SSH from here. Okay. Okay, we'll check for SSH from here. Still, we'll take SSH. And let me try one more time. Admin. What was the command? Command was show SDWAN policy data filter. Show SDWAN policy data filter. And we're getting it. Let me try one more time to inject the traffic again from here. So I will go here. Ping. Target 10333. Right. Repeatedly with 5. Extended yes. So span 222. Right. DSAP I want to use 26. 5 packet. Let me go here and check it now. Even this counter is not increasing. Okay, increase that. So this is by default landing in the class 3 only. Okay, so what I can do that already we are getting late. So I will check in backend. Okay, there might be some slightly issue because we are running in the new iOS, but this should work 100% going to work. This is my commitment. So I will do testing tomorrow. Will it fine for everyone? Just testing and pending. So I will do testing tomorrow.
Yeah.
All right, so let's continue from tomorrow and I will do the testing. Only testing is pending, so I will check it. Don't worry. Thank you.
So today class only for the policies, huh?
Yeah, QoS policy, only one policy, QoS policy, quite big QoS policy. Only testing is pending, so we'll continue testing tomorrow.